All right, so we're talking 4.8 part 2, quadratic inequalities. This time we're asked to solve quadratic inequalities. Before we graphed and we shaded, okay? So be careful. There's like a really, it's only a slight difference in the directions. So be careful and notice the directions. If it says graph the inequality, you just need to graph it and then you shade. This one, we are asked to solve the quadratic inequality, meaning what is x? All right. So x equals what? When you're asked to solve, that's when you need to figure out what does x equal. All right, so I'm going to show you guys two ways to solve quadratic inequalities. And then I'm going to have you guys vote. All right, and every single person's going to vote which method they prefer. Which method they prefer. All right, so I'm going to show you guys both, and then I'm going to have you guys vote. All right, so the first way is the graphical method. The graphical method. All right, so number 3, I'm going to use the graphical method on, and then I'm going to show how you do it with the second method, which is the algebraic. All right, so the graphical method is literally you're going to graph y is equal to x squared minus 6x plus 5. Okay, so we're going to graph this first, and you can use whatever method you want. You can put it into vertex form and then graph it, or you can use our old school method of negative b over 2a. Since we haven't done that in a while, I'll go ahead and do that method just to kind of refresh your memory. All right, so I'm going to find the vertex by doing negative b over 2a. So that's negative 6 over 2 times 1. And that gets me 3. Plug that back in to get y. So 3 squared minus 6 times 3 plus 5. I get 9 minus 18 plus 5, which is negative 9 plus 5, giving me negative 4. All right, so my vertex is 3, negative 4. So positive 3, negative 4 puts me right here. And a is equal to 1. All right, so I'm going to go up 1 over 1, up 3 over 1, and then up 5 over 1. Sorry, let me make this a little nicer. All right, and I get this graph. Okay. Now here's the thing. Sometimes students will want to start shading like inside the parabola, but no, that is not what I'm trying to do. I'm trying to solve for x. I need to figure out what x is equal to. So when you're trying to find out what x is equal to, notice we have greater than 0 here, right? So if I want to find out when is this graph greater than 0, I'm literally looking for the part of the graph that's above the x-axis, right? Greater than 0, positive. So right here, okay, this piece is above the x-axis. This piece is above the x-axis. This yellow piece is below the x-axis. It's negative, right? And on the x-axis, that's when it's equal to 0. Okay. Since it's just greater than, there's no equal to, I have open circles there, right? So I don't want to include that. So my final answer then will be x is less than 1, right? That's this piece right here. X is less than 1, or x is greater than 1, 2, 3, 4, 5. And that is my final answer. Okay, questions?
Wait, Miss Leong, I have a question.
Yes, Yanni.
So for this question, are we going to use like the dash?
Nope. Because there's no equal to, that's why this no equal to. Because
Okay.
it's not asking us to graph the inequality. If it said graph, like if it said y is greater than this, and then you need to graph, then I would have dashed and like,
Okay. Okay. Thank
but
you.
we're not asked to graph, we're asked to solve. So that's why I have x is less than 1, x is greater than 5, and no equal signs. Yeah, good clarification.
Can you scroll to the top again?
Yeah.
Like of the page?
Oh, of the page? There's nothing up there. Really? Yeah. Okay. All right, so that's the graphical method. All right, that's the graphical method. For the algebraic method, let me go and show you guys this one. And again, I'm gonna have you guys vote on which one you like better. All right, so the algebraic method, it's the same kind of concept, okay? This time, I wanna find out when x minus 6x plus 5 is equal to 0. I just wanna find out when it's actually equal to 0. So I notice I can actually factor this, I believe. See, -5 times -1 is +5. Cross multiply, yep. All right, so x minus 5, x minus 1 is equal to 0. All right, so that I have x is equal to 5, x is equal to 1. Okay. So I'm going to imagine this on a number line. So I have 1 and I have 5. Okay. That's where it's equal to 0. So this is your x-axis basically, similar to our graph here. Okay. So 1 and 5 is where it hits the x-axis. Now notice here, A is positive, all right? A is greater than 0. So I know that this parabola goes up, right? Since A is greater than 0. So basically it'll do something like that, right? If A was negative, it would do this, all right? But A is positive. So this part is above the x-axis. This part is below the x-axis. And this part is above the x-axis. And now to get the final answer, you just look at your inequality. And that tells you, do you want the positives or do you want the negatives? Since it's greater than 0, you want the positives. So I want this when x is less than 1, x greater than 5. No equal to, since there's no equal to here. And that is your final answer. All right, so those are your two methods, guys. Graphical and algebraic. So I want you to think which one you like better. And then I'm gonna have you guys vote in a sec. First thing is look at the directions. This says solve. So I need to figure out what does x equal to, okay? All right, again, I'm trying to emphasize that this is different than graphing inequalities. All right, make sure you notice the difference. Okay, so number 4, let me go ahead and do the graphical method, okay? So the graphical method, I'm gonna go ahead and graph y is equal to x squared minus 4x minus 12. So I get x is equal to -b over 2a. So -4 over 2 times 1. leaving me with 2. Plug that in for y. And simplify. All right, so I get a vertex of 2, -16. Now, when you guys do the graphical method, you can definitely do like a sketch. You don't actually need like the graph paper. So I'm gonna go ahead and use just a little sketch of 2, -16 here. All right, and oh, actually the sketch is a little bit tough. Okay. A is 1, so I'm going to go up 1 over 1, up 3 over 1, up 5 over 1. All right. And if you had graph paper, okay, this would be -2, and this would be 6. All right, I just don't want to flip back and forth. So if you had graph paper, you would be able to go up 1, up 3, up 5, and then you see that it hits the x-axis at -2 and 6. All right, so at this point, I'm going to look at my inequality, which is less than. So I want the part that's below the x-axis. All right, no equal sign. So open circles. So I have x between -2 and 6 as my final answer. All right, this is the positive above, this is negative, and this is positive. So you want less than, meaning below the x-axis. All right, any questions on that? All right, guys, let's go to number 6. All right, so I'll switch it up. I'll go algebraic on this one. Okay, so algebraic, first thing, move everything to one side, set it equal to 0. Okay. Now, if you want to rewrite this, we want to find out when it's actually equal to 0. And we can factor that using difference of perfect squares. Oops. And I get C is equal to -3 or +3. All right, so on my number line, I have -3 and +3. Now here, A, right? A right here is equal to just 1. So since A is positive, I know that it's going to be facing upward. So my graph would do something like that. All right, so this is positive, this is negative, this part is positive. All right, and now I look at my inequality and I have less than or equal to 0. So I want the negative part. All right, so that means I want this piece from here to here in solid dots because of that equal sign. So C is between -3 and 3, including the -3 and 3. All right, any questions on that? Okay, let me go ahead and start having you guys help me out. All right, so number 8, let me call on all right, Sebastian. Okay, Sebastian, which method did you like better?
Algebraic.
Algebraic? Okay. I'll be honest, I kind of like algebraic better too. Okay, so algebraic. So Sebastian, what should you do first if you're going to do algebraic to solve for x? Let me show you the example above to kind of help.
Oh yeah, no, you just factor it.
Good, factor it first. Yes. So
Go
ahead and
it's x minus 5 squared is greater than 0.
Good. And we're actually just going to find out when it's equal to 0 first.
Oh.
Okay. So x is equal to what? Will equal to 0.
5.
5. Good. Ooh, so this is a little interesting. We only get one answer on this one. So let's think about what this looks like graphically. So what that tells me is it only hits the x-axis right at 5.
Oh, so it's a vertical line?
Well, no, it's still a parabola because it's square.
Oh.
Yeah, it's still a parabola. So your two options here, Sebastian, are it can either do this.
Yeah, or go the other way.
The other way, exactly.
Yeah, but it's greater than 0, so it can't go downwards.
Well, no, it can. What you have to look at is you have to look at A, right?
Oh.
So
yeah, A is positive.
There you go. A is equal to 1. So since A is positive, then it does what?
It goes up.
Good. It faces up. Nice. So then this, I'm going to erase this, is not the right one. All right. And it's that one above. All right. Good. So that is what we have. So that means, oh, okay. So it's positive here and it's positive here. All right. It's both parts of it. Everything's above the x-axis. And we're looking for when that graph is greater than or equal to 0. So, Sebastian, what do you think the
It's
answer?
inside.
Say it again.
It's colored inside.
It's colored inside? What does that mean?
Inside the parabola.
No, we're not graphing the inequality. We're solving for x.
Okay.
X is what, right? We're not shading. That's not the question.
Okay.
We're not graphing the inequality. We're trying to figure out what is x. So this is the graph.
Yeah.
Right? When is this graph positive? When is that graph above the x-axis?
When it's not 5.
Okay, or sorry, when is it above or on the x-axis?
Also all real numbers.
There you go. All real numbers. That is your answer. Because here it's positive, here it's positive, here it's equal to 0. So that satisfies all of that inequality. Does that make sense? Sebastian?
Yeah.
Yeah? Okay. Quick question, Sebastian. What if this said less than 0? When is that graph less than 0?
Never. No solution.
Good. Yep. So if that said less than, then we would say, nope, no solution, because it's never negative. It's never less than 0. Good. All right. Nicely done, Sebastian. Okay. Let me go to number 5. All right. And honestly, guys, I think algebraic is the easier way and it's more precise. So I'm just going to encourage you to practice the algebraic. And since most of you voted for that, I think we'll skip or we'll stick with that one. Okay. So let me call on someone else for this next one. Angie, number 5, help me out with this one.
You want to factor it first, so it'd be like x. think like x. Wait.
So it's already set equal to, or sorry, one side is already 0. So
Mhm.
we need to figure out when is this exactly equal to 0. So what can I do to find that out?
You factor it first.
Good, yes, factor it first. So how does this factor?
X plus 6 minus, and then x minus 1. I don't,
Okay, we'll start with what times what equals 2x squared
x times x.
for the 2x squared. So to get this first one, it's not just x times x, right? Because x times x would just get me x squared. How do I get 2x squared?
Wait, can I do it my way first? Because I kind of do it a different way.
Oh, okay. Yeah. Go ahead and do it your way. Yeah. Just go ahead and everybody factor however you want, and then just tell me what you get. All right, and Angie, just tell me once you have it. Okay, so 2x minus 1 and then x plus 3. Okay, so we're trying to figure out when it's equal to 0. So for this first factor, x is equal to what? We'll make that equal to 0.
X is equal to 1/2.
Good, and then what about the next one?
X is equal to -3.
Perfect, nice. Okay, so from those two, that's where this graph would hit the x-axis, 1/2 and at -3. Okay, so now Angie, is A positive or negative here?
Positive.
Positive, good. So what does that tell us?
It goes upwards.
Perfect. All right, so it goes upwards. So this is what it would look like. Okay, so this is above the x-axis, this is below the x-axis, this is above the x-axis. Okay, now the question is, well, what part do I want? So Angie, what part do I want? Above or below the x-axis?
Above.
Good, and why?
It's greater than or equal to 0.
Perfect. Greater than or equal to. So that's this part right here and this part right here, and equal to, meaning solid dots. So I want this part and this part. So x is less than or equal to 1/2, or x is, oh, shoot, I switched those around, my bad. Hit, switch. I forgot that. That was a negative, my bad. This is -3. This is 1/2. All right, so this is x is less than or equal to -3 or greater than or equal to 1/2. There we go. All right, nice job, Angie. Okay. All right, guys, go ahead and try 7 and 9 on your own. 7's a little tricky, so I want you to try it and then compare your answers with mine and see kind of where you get stuck, or if you're actually able to go all the way to the end. All right, so try number 7 and 9, and I'll work alongside you. And oh, sorry, actually, oh, I do need to make an adjustment. Make this greater than 0 before you get started. Make that greater than 0. All right, hopefully you guys got at least up to this point where you realize that is not factorable. Do you guys realize that? Okay, so when it's not factorable, you have to use your other methods of solving, right? Completing the square, you can definitely do that. Or you can use quadratic formula, which is what I did. And I found imaginary answers. Okay, so what that means when you have imaginary, or I should say complex solutions, sorry. When you have complex solutions, is that you either have a graph that's entirely above the x-axis or entirely below the x-axis, because it does not hit the x-axis. That's what it means when it has complex solutions. It does not even hit the x-axis. So since a is greater than 0, right? Since a is 1, it's going to be facing up. So that means it is this situation, right? It's entirely above the x-axis. So since I want to find out when is this graph greater than 0, right? When is this graph positive? Well, the entire graph is above 0. So this will be, once again, all real numbers. All right. So that one was a little tricky. Okay, so that's what happens when you get complex solutions. Okay, you have one of those two situations, depending on if A is positive or if A is negative. All right, go to the last one. Try this one on your own.